Student, in the previous class, we discussed up to subtraction of vector and the concept of relative velocity and some properties of vector addition. Regarding this, already I sent some numericals to your group. All of you see that numericals and solve. If you have any doubt, please send to me. Some of your friends already solved this numerical and send me the answer. So there is a request to all of you, please see all the numericals which I sent to your group. Today, I'll start with the concept of rectangular component of a vector. Okay, so what do you mean by rectangular component of a vector? Whenever a vector is resolved into two components such a way that the two components are perpendicular to each other, then these two components are known as the rectangular component of the vector. See the diagram. Here we take a vector A which is represented by OP by making an angle theta with x-axis. Okay, so now to determine the rectangular component of this OP vector, we draw the perpendicular from the point P on x-axis as Pn and on y-axis as Pn. So therefore ON, which is represented by AX vector, and OM, which is represented by AY vector, are the rectangular component of the vector A. So now we have to determine the magnitude of this rectangular component AX and AY, and we have to represent the given vector in terms of their rectangular component. Now see the diagram very carefully. If we take the triangle OPN, so triangle OPN, okay, so now from this triangle, if we use the triangle law of vector addition, just see ON and NP are taken in same order but OP are taken in opposite order. That's why OP vector is equal ON plus NP, and similarly NP is equal to the ON. So that's why we can write in place of OP A vector is equal, in place of ON AX vector, plus in place of NP which is equal to ON AY vector. Okay, or A vector is equal AX I cap plus AY j cap, where I cap and j cap are the unit vector along the x axis and y axis. Okay, so now in this statement, AX and AY are the magnitude of AX vector and AY vector, known as the rectangular component of A. Now we want to determine the magnitude of this AX vector and the magnitude of this AY vector. Clear? To determine the magnitude of AX, we take the triangle OPN. We take the triangle OPN of this triangle cos theta equal base by hypotenuse, that is ON by OP. That's why I write here cos theta equal ON by OP. And ON is equal AX and OP is equal A. That's why AX by A. And from here AX is equal A cos theta. So this is the magnitude of X component of the vector A. Again, using the same triangle, if we take sin theta, sin theta is equal perpendicular by hypotenuse. That's why NP by OP. So therefore sin theta equal NP by OP, and NP is AY and OP is A. So therefore AY equal A sin theta. So this is the magnitude of another component of A vector AY. Clear? Now if we square these two equations and add with each other, we got an equation like AX square plus AY square equal, from the right hand side we can take a square common and within bracket sin square theta plus cos square theta, which is equal to 1. Clear? So therefore a square equal ax square plus ay square. So therefore a equal root over of ax square plus ay square. So this is the formula by which we can determine the magnitude of a given vector having rectangular component as ax and ay. Clear? And the angle theta in the figure we can determine by the formula tan theta equal from this triangle. Tan theta means perpendicular by base, that is ay by ax. So this theta is the angle which makes by the a vector with x-axis. Clear? So this is the overall concept of the rectangular component of a vector. And one thing you remember, wherever a vector gives like this, we can determine the magnitude by this formula. Magnitude of this vector a equal root over of ax square plus ay square. Clear? Next, we move into the concept of resolution of vector in three rectangular component. Three rectangular component means we consider here a vector which is represented by OP in three-dimensional coordinate system, that is OX, OY and OZ. Clear? The component of this vector along the three-dimensional coordinate system, that is along OX, along OY and along OZ, are known as the three rectangular component of the given vector. So now in this figure, OL, which is AX vector, is the x component of a vector. OM, which is AY vector, is the y component of the vector A, and OR, that is AZ vector, which is the z component of the vector A. Now here we have to again write the expression for A in terms of AX vector, AY vector, AZ vector, for which we take the triangle OLQ. See here, OLQ. Of this triangle, OL and LQ taken in same order, but OQ taken in opposite order. That's why we can write OL plus LQ. OL plus LQ is equal OQ, is equal OQ. Clear? Again, just see, OL plus OR. In place of LQ, we can write OR because both sides are same. So therefore LQ equal OR. That's why I write here OL plus OR is equal OQ. Okay, consider this equation as 1. Now from the triangle OQP, again see, OQ and QP are in same order, but OP are in opposite order. That's why from this triangle we can write OQ plus QP. OQ plus QP is equal OP. Clear? Or OQ plus ON. In place of QP we can write ON, which are equal. So that's why in place of QP I write ON equal OP vector, which is equation number 2. Now putting the value of OQ from 1 in the equation number 2, we get OL plus OR vector plus ON is equal OP vector. Or now see the diagram. That is OP, which is our given vector A vector, is equal, what is OL? X vector, plus what is OR? That is AZ vector, plus what is ON? That is AY vector. So therefore we can write A vector is equal AX of I cap plus AY of j cap plus AZ of k cap, where I cap, j cap and k cap are the unit vector along x axis, y axis and z axis. Okay, so this is the representation of a vector according to the three rectangular component. Clear? Now again we have to determine the magnitude of this vector. Okay, so how can you determine the magnitude of this vector A? Again we use the triangle OLQ. So now from this triangle OQ square equal OL square plus LQ square. So OL means AX, clear, and LQ means OR, actually that is AZ. So that's why AX square plus AZ square. Now again from the triangle OQP, clear. So now OP square equal OQ square plus QP square. OQ square plus QP square. Clear? And OQ square from the previous expression AX square plus AZ square. That's why in place of OQ square I put here AX square plus AZ square plus and QP. QP is equivalent to ON, which is AY. That's why AY square. So therefore A equal, that is OP square means A square, means A equal root over of AX square plus AY square plus AZ square. So this is the formula for determination of magnitude of a vector whenever a vector given in three rectangular component like this. Clear? Okay. Now we move into the concept of direction cosine of a vector. What do you mean by direction cosine of a vector? We consider L, M, N are the direction cosine of the given vector A. What do you mean by direction cosine? Direction cosine means cosine of the angle of a vector mixed with x-axis, y-axis and z-axis. Okay, so therefore L is equal cos alpha, where alpha is the angle made by a vector with x-axis. Clear? Okay, so now this cos alpha, you just remember the cos alpha is equal x component of the given vector by magnitude of the given vector, that is ax by a. Similarly, M, which is the direction cosine along y-axis, that is cos beta. What is beta? The angle made by the given vector with y-axis. So therefore cos beta is equal y component of the given vector by magnitude of the given vector, that is ay by a. And similarly N, okay, which is the direction cosine along z-axis, that is cos gamma. What is gamma? The angle made by the a vector with z-axis. So cos gamma is equal z component of the given vector by magnitude of the vector. Okay, clear? So by this three direction cosine, we can find out the angle made by a given vector with x-axis, y-axis and z-axis. Clear? So now if we square the three equations both sides and add with each other, then we get here L square plus M square plus N square in the left hand side, and in the right hand side A square is LCM ax square plus ay square plus az square, and from our previous explanation ax square plus ay square plus az square is equal a square. That's why this becomes a square by a square means 1. So this is very important conclusion. What? The sum of the square of direction cosine of a vector is always equal to 1. This is very important theoretical questions. Okay, and this resolution of a vector either in 2 component or in 3 component are very effective. There are some questions may asked on this resolution concept. What type of question? Number 1, very important, see it carefully. Why the pulling of lawn roller is easier to push? This is very important questions. Another, our walking is also we can explain with the concept of rectangular component of a vector. Thank you student, see it carefully, and also I send some numerical, you see all the numericals carefully. Thank you.